to Eaton Tech Talk. This is, I got Scott Brady with me. Tom Dimitrovich here and Scott Brady. Scott, we'll let you do your introduction here in a second, but so just so everybody out there knows, you are tuned into a discussion on NFPA 70B, which deals with maintenance. And with me, I have Scott Brady, the Scott Brady. Scott, why don't you tell some people about you?
Hi, everyone. My name, of course, is Scott Brady, and I work for Eaton. I'm the manager of the technical application support team for Eaton. I've been with Eaton for 29 years. I started as a field service engineer doing maintenance and testing of electrical equipment. Tom and I both serve on NFPA 70B, and we're here today to answer any questions that you might have about the new revision for 2023.
Absolutely. So, Scott, where are you located again?
I'm in Phoenix, Arizona.
Phoenix, Arizona. So you 2 hours behind me. I'm in Weird and West by God, Virginia. So you 2 or 3 now?
3 now. Yeah,
3 now.
We're one of that. We're the strange state that does not change time zones. So.
That's right. There's just a few out there. There's not many.
Yep.
But that's okay. So 70B. So this, if you were, I know you recall this, but probably people out there don't know this. But we basically, you and I did a program called Changes in NFPA 70B. And this was on March 21st at 2:00 p.m. This is a follow-up session to that discussion. Basically asking, we're going to answer some questions. If anybody's out there who wants to answer questions, use the chat box on either YouTube, Facebook, or LinkedIn. And let me just double check. I can see if, because sometimes on LinkedIn, it doesn't show up. I'm going to hit pause and I'm going to come over to this. Use the chat. There we go. That way I can see the chat boxes on LinkedIn if we have to. And I can comment on LinkedIn, but anybody can use that chat box. But we're going to continue our discussion on this. So we got Robert from Omaha. Oh, Robert from Omaha, greetings. Yes, only I know. So Robert, you got to hit so here's the thing, Robert. And Scott, this is what I tell everybody. When they come and they're watching this stuff, they got to hit the thumbs up to like it. And if they want to hit the thumbs down, they have to hit it twice. Or any multiples of even numbers. 4 times, 6 times, whatever. If you really don't like it, hit it 8 times. So, and if you like it, just hit it once. That's all it takes. All right. So use the chat for questions. So now I say we talk a little bit about as we're going through here. And you had a good idea about taking a look at a piece of equipment. And let's talk about doing I guess it would be creating a maintenance plan, right? For some piece of equipment.
Correct.
What do you suggest?
So I was thinking maybe we could start with something very basic, like a 480 volt, 1200 amp panel board, and assume it has a 1200 amp main electronic circuit breaker, multi-case, and maybe 225 amp feeder multi-case circuit breakers.
All right, so we have 480 volt, 1200 amp panel board. What else? Was it? You had 1200 amp main.
1200 amp main.
Yep.
Multi-case circuit breaker with an electronic trip unit, because when we go through the tables, we'll kind of see how that matters.
Okay.
And then go with the 225 amp thermomagnetic breaker feeder breakers.
Okay. So we have a 480 volt panel, 1200 amp main with an electronic trip unit, all multi-case circuit breakers, 225 amp thermomag breakers, probably feeders, and they're thermomag. All right. Now, I will just tell everybody that I would highly suggest that you grab your 70B book, and if you guys and gals out there don't have a 70B book, then I would hope that you go out to NFPA link and get your subscription. And if you have a subscription, then all you need to do is go to your favorites, because I'm sure you highlighted 70B 2023 edition as your favorite, and then click on it and go into it. But if you don't have NFPA link, you got to go out and get it. It's a very low monthly rate. It's I wish I could get a percentage of all of those NFPA links that I've thrown over to NFPA's way, but in any case, get your subscription, and then you can navigate through NFPA 70B. We'll go in and out. Scott and I will go in and out. And Robert says he's got both the book, and that's excellent, Robert. So we'll go in and out of NFPA 70B, but the main discussion right now is 480 volt panel board, 1200 amp main. So the first step, Scott, now is this, and as I'm going to assume this is an installed piece of equipment, right?
Correct.
All right. So we've got a plant. We have an installed piece of equipment. What's the first step if we're going to establish our maintenance plan?
I think the first thing you do is you go to the specific equipment chapter of the piece of equipment that you're looking for. So in this case, it would be chapter 13, which is panel boards and switchboards.
Right. So we'd go into, just to give everybody an overview, we have chapter 1 is administrative, reference publications. You're going to scroll all the ways down to chapter 13 for panel boards and switchboards. And this will tell you that it's okay. So it's a 480 volt panel board. So we know it's within the scope of 13.1 of chapter 13 because it's 1,000 volts or below. All right. So I'm in chapter 13. And we know that it doesn't address the requirements of individual components of panel boards. But you said it has circuit breakers in it. So what does that mean?
Right.
What does that mean?
So that means that we're going to, after we look at the panel boards, we're going to have to go to the equipment chapter on circuit breakers, which is chapter 15. So we're going to start. Yeah.
So 13 is panel boards, 15 is circuit breakers, and that covers low and medium voltage. Okay. All right. So
I see there's a question on condition of maintenance versus operating condition, and I think we'll answer that through this process too. So
very good point. Very good point. All right. So chapter 13. What are we doing first?
So that first section that comes up there, or actually third section, 13.2 is frequency of maintenance. So, we're writing our maintenance plan. So we need to go to chapter 9, which has the maintenance intervals in it.
Yep. And then we got to go to the table.
We have to go to the table.
Table 922, maintenance intervals, and we got to find our panel boards and switchboards. So this is going to tell you now. First of all, the very first line item in this table, if I'm not mistaken, all equipment infrared thermography annually, and that
Correct.
is regardless. And so that's the first thing you got. I think important thing. Whoop. I don't know there it is. So you have conditions 1, 2, and 3. And we know we're going to have to do thermography. So how do we do thermography on a panel board annually? You have to take the covers off for that, right?
You either have to take the covers off, or if you have IR ports installed, which you can on panel boards, you could do that without having to take the covers off and reduce your risk.
That's right. So
because we do make IR parts that go to the gutters.
That's right.
Of them. So,
That's right. And in fact, in the Experience Center, I took some photos of that. In the Experience Center, we have in the gutters, it's a long rectangular strip that you open that door and you can do thermal scan right down through, and you don't have to expose your workers to energized parts. That requires no dress, right? Because it's all operating as it's designed, so you don't have to worry about, other than boots and whatnot, just for being in the area. You don't need arc flash or shock protection, things like that. All right, so we know we're going to do thermography annually, right? Unless it's condition 3.
At least annually, unless it's condition 3.
So I guess the next step is we've got to determine the condition of the equipment.
So that's in section 9.3.
So that's 9.3. 9.3, equipment condition assessment. All right.
So this kind of goes to where that question is coming from. So the first one is the physical condition of electrical equipment. So let's say that this is a new installation and it was installed, a year ago.
Right.
So that would, if we look at 9.3.1.1, which you scroll down just a little bit. So we would say, like new condition, let's assume that it's enclosure's free from moisture intrusion and tight. No unaddressed notifications from continuous monitoring systems. There are no active recommendations from predictive techniques. And at this point, there's been no previous maintenance. So we're within the guidance of the EMP right now. So
that'd be like this type of equipment, right?
No, I think that might be a 3.
That might be a 3. That might be a run and replace.
Yeah, that would be a run and replace, I think, right there. So
all right. So if it's new equipment, and so it says continuous monitoring system. So the 70B recognizes if you have a continuous monitoring system that would basically looking for things like humidity, moisture, any type of moisture, temperature, right? And I know there's an IEEE committee that is Thomas Plunkett says, does Eaton have thermography tools? We don't make the IR scan. We give you access for your thermography, right? We don't make the thermography IR scan, do we?
No, we don't. And we do install permanently mounted thermal sensors if that's desired as well, which would also be another way of not being so invasive on the equipment to do thermography and having to remove covers, is to have permanently installed sensors inside the equipment. Some customers do that, especially on medium voltage equipment. So they don't have to remove covers to do thermography or detect heat.
Yeah, and that's your typical. I know that I'm just looking to see if I had a photo here, because I could have swore that I remember being up in the Experience Center, and we have some equipment there that has the IR windows in them. And what's really cool is especially for a panel board, we have, here it is right here. And I'm going to mute this real quick. But look at this. Oh, hold on. I got to get out of presentation mode. And that's still not showing it. Well, maybe later. So to our point there, here it is. There we go. All right. And I'm just going to show this real quick. I'm going to mute it. And then this should work now. There we go. So that is on the panel board, right? So that's the trough of a panel board or a switchboard. And then you open and close that little door, and then you have access to
the gutter.
to that gutter. Yeah. And there's another, this is another, that's an Iris makes that one. So we'll put that product inside. You can open the door and see visibility to all of those connection points. And I just think that's an awesome. And look, this is a different size window, right? So this is like an integrated facility system where there's a transformer in that enclosure. And that, what do they call that? Honeycomb? Yep. So that honeycomb gives you access to see all of that. And now you're on this side of a closed door. And NFPA 70E tells us that when you have equipment with the doors closed and everything operating correctly and well maintained as per 70B, then you're not worried about an explosion or anything like that when you're standing in front of the equipment. So I just think that's absolutely awesome. And then you just can close that and open it. And I like, watch this. And you look inside and there's all your terminations. So piece of cake. Anyway, I just want to at least, so thermography is going to be important. We can adjust we're going to talk about, what do you call it? The frequency based upon any continuous monitoring and predictive techniques. All right, Thomas Plunkett, you're welcome, buddy. Thanks for the question. All right, so where do we go?
So we're back to the equipment condition assessment.
Oh, that's right. So the first one was physical condition. That's new. That's condition 1. Do you want to cover condition 2?
Absolutely, because I think condition 3 or
2. So now this one says if you have maintenance results that deviate from the past results or have indicated more frequent maintenance in accordance with manufacturer's published data. So if the manufacturer, I guess what that means is if you've done maintenance in the past and you've had to check something that says you need to do more frequent for whatever reason. Now, maybe it's a temperature, maybe it's like that other picture that we had where you had some damage and you go, look, this is something that you're going to have to do more frequently, I guess. And then you have the maintenance cycle that if you had to replace components. So I guess, have you ever had to, let me ask you a question. So you've done this before. If you go to a customer site, have you ever done I don't know, whether it be thermography or any of the maintenance procedures on equipment where you said you had to replace a component?
From thermography itself?
Or any maintenance, whether it's thermography or whatever.
Yeah, absolutely. We've definitely done thermography and seen breakers that were glowing almost visibly.
Oh, wow.
Really? So, it was so scary that thermography was almost not even necessary.
Your eyes were your thermography.
Yes, and this was in a box store. So there was a connection issue inside of the circuit breaker, and it was very evident that there was a severe heating issue going on inside of the circuit breaker. So we immediately took an outage and replaced the circuit breaker.
So when you say a box store, they make big boxes or little boxes there?
Without revealing the name of the particular box store, that's just a generic way of saying box store. So.
Like retail, right?
A retail store, correct.
Cool. Okay. All right. And then a condition 2 also is if you have notifications. So if you have give me an example of a continuous monitoring system that you think would qualify for this?
Right. So Eaton makes a product called InsulGuard, which is a partial discharge detection protective relay. And that will continuously monitor for partial discharge Very useful on rotating machines, medium voltage rotating machines, switch gear. And when you see this, um, it sends off an indication if it detects the partial discharge, and that'll give you time to plan your outage and look for a replacement part or component or whatever it is. And you can kind of even use it depending upon the sensor placement to kind of determine where you're having the issue as well. So
Oh, so this is an example. InsoGuard, isn't that more that's more of a medium voltage application, right?
correct, yes, because you're not going to get the detection, the corona discharge and the discharges that are used to detection unless you're above 2.4 kV. So
Gotcha. And look at that. So if you have predictive diagnostics in the equipment, now this is medium voltage, but there's no InsoGuard for like a 480 volt panel board, which we're talking about. So what would you think in a 480 volt panel board, what would be a good example of continuous monitoring?
So many new trip units have breaker health features. And so those breaker health features might be something that could tell you that, you might have an issue and to plan an outage to take a look at it. We also have some new transfer switch controllers with health features as well.
Yeah. Oh, look at this. So this is circuit breaker health. Keep your facility online and safe. So, and I know in this discussion, in this video, they talk about being able to know. So let's just look at that real quick. It knows short circuit currents, how many overloads it stopped, how many operations, the temperature, and the runtime. So these are 5 very important parameters that if you had that information and insight, you could ascertain whether it's a condition 1, 2, or 3, right? And if one of the maintenance procedures is to cycle the circuit breaker, this will tell you the total runtime. It'll tell you the number of operations. So you might have a circuit breaker that is constantly being turned on and off. That might be a bad indication too, right?
Right.
It may not be good. It's one thing to say, hey, annually you have to turn this breaker on and off. It's another thing to say, hey, this thing's been turned off 300 times in the last 2 months. So the number of operations, whether it be manual or because of overloads or short circuits, it could be even manual. Switch duty, right? So if you're switching things on and off and using it as a switch, that's a misuse of a circuit breaker. Excellent. So 70B recognizes continuous monitoring, and a condition 2 indicates that if you had notifications from continuous monitoring system since the prior assessment. And then number 4 is if there are active recommendations from predictive techniques. Predictive techniques. I'm not sure if I like some of the words we used. What's a predictive technique?
I think the committee was trying to say, if you had done repeated tests and it was showing the insulation was degrading or, kind of showing a bow or something in your tests over the previous maintenance cycles, that would be kind of an indication that, you might want to increase your maintenance cycle because you might be getting near the useful life of that insulation. And I think that's what the committee was thinking for that particular comment.
Yeah, that could be. And then the other thing is, like, if one of your predictive techniques is to monitor temperature, and you notice that it's a continuous elevated temperature on a piece in and around that piece of equipment or that device, then you might say, look, this is seeing a lot of temperature, and the active recommendation may be to either do more thermography or possibly try to remedy the situation. It may be that someone says, hey, we need to cool this room and put an air conditioner in here because it's getting too hot. or find a way to ventilate and get some air circulation. So those might be active recommendations based upon the predictive technique might be temperature based, and the active recommendation could be to provide air circulation or cooling or something. I don't know. I think there's a lot of room for improvement in the language.
Yes.
So physical condition 3. So I've got a panel board, and I'm going to ascertain whether or not it's physical condition 3.
So that's equipment has missed the last 2 successive maintenance cycles in accordance with the EMP. Previous 2 maintenance cycles have revealed issues regarding repair or replacement of major components. There is an active or unaddressed notification from the continuous monitoring system.
Okay.
And there are urgent actions identified from predictive techniques.
Urgent actions. So so you think about it, you have to ascertain the condition of maintenance, and this needs to be done before you can even determine how frequently you're going to perform the maintenance. And if you're going to do something different than that's already in the table. So there's a condition 1, 2, and 3. So urgent actions identified from predictive techniques. I would love to have some good examples of that, but urgent actions. I just think of the song "Urgent" from Foreigner. I think it was Foreigner or Journey. Anyway.
Yes.
Yeah. So you have a condition 1, 2, and 3, and that's going to dictate. And that picture I showed earlier, this one here, right? So this picture here, where you have a piece of damaged equipment, it's obviously damaged. You can see that, and I think this one here was actually hit by. Look at that. The whole corner is damaged, and this whole center piece is just. That would be almost inserviceable. I mean, this is something I believe would have to just be simply replaced, because you're not going to pull maintenance on a piece of equipment that has that much damage.
Right.
And I think there is. Yeah. There we go. What about this one here? 9315. Equipment exhibiting characteristics that do not conform to any of the above conditions shall be identified as requiring corrective measures before returning it to a normal operating condition. I think that this, if you found this in your facility, you would say this is a non-conforming equipment, and you're going to have to take it out of service, and you're going to have to make corrective measures. Possibly, I would say you're going to replace that panel boards, because then you got to go back to the NEC and manufacturer's instructions that tell you what you can and can't do with a panel board. Can you recondition a panel board? Because once you start replacing pizzas and parts to a panel board, you have to figure out whether or not you can replace it or recondition it, right?
Correct.
All right. So you've got non-conforming equipment, and that might be okay. So that's the physical. Okay, now you have two other categories, right?
Correct.
Criticality condition. What say ye about criticality condition of equipment? This is kind of this language was changed quite a bit. For those of you watching, you can imagine there was a lot of discussion, especially from the end users who have to live with this document. So the language was changed quite a few times with debate. So condition 1 or 2 for criticality shall be permitted to assign where the failure of equipment or system will not endanger personnel. And then 3 was assigned if it will endanger personnel. So I think Tom and I touched on this a little bit during our other meeting, that there was an environment component to that previously that was deleted because. Well, no, you know what it was? It was financial.
Or financial.
That's
yes,
what
correct.
it was, because then the next one is the operating environmental condition. So the criticality of the condition was also the critical nature of the equipment to the process. That's what I think, because quite frankly, any electrical equipment that fails, I mean, if you have 480 volt panel board and it fails, I don't know what failure mode that it would not endanger personnel. I mean, that would be hard to ascertain and determine the likelihood of that. I mean, if you have a 40 volt panel board, like we're talking here, and it fails, I don't know how you could assign it a criticality condition 1 saying it's not going to hurt or endanger personnel, unless it's maybe, I don't know, maybe it's in an area that nobody goes to. I don't know. You would have to say no one ever goes in that room and no one's allowed to go in that room. But I don't know. And a lot of this equipment has to be readily accessible or accessible. So I just can't see. I think this puts a risk of being able to give something, even a brand new piece of equipment. Like we're talking a brand new piece of equipment. Can you give it a condition 1 saying that the failure of that equipment will not endanger personnel? I mean, what do you think? That's a tough one.
Yeah, it's a tough one. I mean, unless it's like arc resistant or something like that. I mean, where it's specifically made to protect personnel.
And unless
It's normal equipment, it's not really, it's meant for system continuity. It's not necessarily meant for protecting personnel.
yeah. So in any case, so 1 and a 2, and you would have to determine which is your, like where you're at on that. So for this new panel board, so Tate says probably this was discussed in the past webinar. Does the standard separate service feeder and branch electrical equipment maintenance, or the EMP can set the prioritization in the electrical system? That's a really good question. And Scott, I don't know where your head's on this one, but my gut tells me it does not. It looks at the condition of the equipment, period. If it's a panel board, like we're talking a panel board, there's nothing in 70B that says this is what you do for service equipment and how you would treat it differently from a maintenance perspective than a feeder panel, right?
Correct. Yeah, there's nothing in there that differentiates it.
Right. And maybe, I mean, this he makes a good point. Tate, I don't know if it's a he or a she, Tatay, but criticality condition of equipment. If what we were talking about, Scott, with regard to if the system, maybe this is what it's going, with a failure of the equipment or system. So let's say it's on my life support system. Okay, this circuit breaker, this panel board is serving my life support system, and we put it as service equipment. And and I come off of that service equipment, I don't have a backup system, even though it's my life support system, because you elected not to do it, design it in, for whatever reason, you decided not to give me a backup generator. If the service equipment fails, now I can die, right? So the system could dictate that my life is in danger if that service equipment fails. So I would possibly say the service equipment could be critical, it could be critical, but maybe a feeder panel board that's not on my emergency system or on my life safety system, that might not be critical from a system perspective. Or the service might be because it serves everything and I don't want to lose my service. What this was supposed to address was the financial aspect too, it's critical to my business. But we couldn't put that in there. All right, so so the answer to that question is it doesn't separate service feeder and branch circuit equipment for maintenance. You would have to do that as the person who's putting together the maintenance plan and prioritize the electrical system equipment appropriately. And this is a bare minimum requirement, so this is just giving you the guidance. So you have criticality 1, 2, or 3, and 3 is if it's going to fail, then it's going to endanger personnel. And then the last one is the operating environment condition of equipment. This is the environment it's in, right?
Yes. So this, I think, is the question that was asked very early on, where we were talking about the question was about operating condition versus the condition of maintenance. So I'm guessing that was about
The environment.
the environment. So if you read that chapter or that specific section, says one operating environment condition 1 or 2 shall be permitted to be assigned where the equipment is used in an operating environment for which it is rated. So it's a pretty generic statement there, but if it's NEMA 3R equipment and it's being used outdoors, then that would be acceptable then, because that's the environment it's rated in. If it's a NEMA 1 and it's being in a NEMA 3R environment or outdoors, then that would not be acceptable. That would be condition 3.
So here's my issue with that. If I have a NEMA 1 in an outside, it's a violation of the NEC. So
yeah, but not everything gets caught on installation. So
that's true. That's true. But so what you could say up front, this is where I'm going somewhere with this, but I think that up front we assume that everything is installed per the NEC, and you have to make sure that the equipment is installed per the NEC. And if it's not installed per the NEC, and then, like, for example, what you just described, you're not going to perform maintenance on it. It's not like you're going to do infrared scanning more often. I would say it meets probably the definition of non-conforming equipment.
Non-conforming.
Yeah. So here's my issue with 933. I think what we were trying to go to, but we didn't get to it, and I think that maybe next cycle we can add this clarity, that if I have, let's say that I have equipment that is installed in a marina on a pier next to saltwater. It's listed for the environment, right? It's in a caustic environment. If I have equipment that's listed for pool pumps and it's in a swimming pool area where you have chlorine and it's in a caustic environment, I'm still, even though it's listed equipment used in that application, I'm still going to want to perform maintenance more frequently on that equipment just because of the environmental conditions, regardless of whether or not the equipment is listed for that environment. What do you think? I mean, do you think?
Well, I think they touch upon that a little bit in the second one, because they do talk about it being in an environment with harsh chemicals, contaminants, or extreme operating conditions. So.
But it says for which it is not specifically rated or evaluated.
Right.
That's the problem I have. I think if I was going to make some changes to this, I would suggest, if like in one where it says operating environment condition 1 or operating environment condition 2 shall be permitted to be assigned where the equipment is used in an environment which does not contain harsh chemicals, contaminants, or extreme operating conditions, period.
Right.
Forget about whether or not it's rated for it, because it's got to be rated for that environment if you're going to put it in as per the NEC. And if it's not rated, then you are in non-conforming equipment. So that's sort of my issue with the operating environmental conditions. And so if you were putting together your maintenance plan, because we have the ability, right, to ascertain whether this is a condition 1, 2, or 3. I might have a marina with equipment rated for outdoors. Implied in that, I could elect to call it a condition 2 or a 3, even though it's rated for the environment. But I know it's in a caustic environment. I still could say this is an environmental condition 3. I'm going to use the condition 3 column of the table up above for my maintenance if I wanted to. Make sense?
Yep.
All right. So those are the 3. Then once you've identified, now, Okay, so let's say that my physical condition is a 1. My non-serviceable equipment, or no, my criticality condition of equipment is a 1. And my operating environmental condition is a 2, because I'm going to be a little bit more conservative. What condition do I affix the equipment?
That is, you pick the highest of the 3, so that would be a condition 2 that you would look under the assessment on.
All right. So I look at each of those. Whichever ones has the highest number, that's the overall condition for that equipment. Then I go to table 9.2.2 and I go to the panel boards row, and panel boards and switchboards tells me condition 1 is the first column, 60 months. Condition 2 is every 3 years. And then condition 3 would be annually, every 12 months. And then I have to do what? The visual, cleaning, lubrication, mechanical, and electrical?
Correct.
Now, is that consistent? I mean, I think that's pretty consistent for most equipment. We tried to keep it in those categories, didn't we?
Yes, we did. We tried to have the same titles for each one. I think there was a little bit of distraction going on, mostly because, we were split up into different groups, and a lot of this was done during COVID, and I think some of that would have been a little bit more cohesive. But I think the committee did a good job of cleaning the ones up that were not necessarily in those categories.
All right, so far we know we're going to do thermography annually. We're going to do the visual, cleaning, lubrication, mechanical, and electrical every 3 years. We've ascertained the condition as a condition 2, and we're golden. Now, Robert from Omaha says, or asks, condition of the operation of the equipment, if maintained or not, does that mean anything? Condition of the operation of the equipment, if maintained or not, does that mean anything? I don't think so. I'm not sure if I understand that. Then he says operating condition, as in new, used, or older equipment. Operating condition, that wouldn't be operating condition. New, used, or older equipment.
Yeah, I think that falls underneath the physical condition category.
Yeah.
So that's the new versus used or older.
Well, I could have new equipment that has a physical condition issue. I could have dented it with a forklift or damaged it, right? It could be brand new equipment. I just put on a wall and I accidentally hit it. And now the physical condition of it is very low, but it's brand new equipment. So I would separate whether or not it's new, used, or older from the condition, because I've seen some older equipment that's in impeccable condition.
If it's well maintained, absolutely.
Yeah.
Yeah.
And that will have an effect as to the operating condition of the equipment at any given point. So the condition, any of those 3 conditions, whether it be serviceability, whether it be the physical condition, then that would definitely impact the operating condition of the equipment. So a measure
it looks like there's a clarification where he says reconditioned equipment. So if you go back to the definition of recondition, is to make in like new condition. So I do believe we would be back in the condition 1 with reconditioned equipment.
That's true. Yeah, because if you took, like I've seen some power circuit breakers that look better probably and act better in a reconditioned mode than they did when they were first introduced. But yeah, perfect. Thank you, Robert. All right, so we know visual is 36, cleaning is 36, lubrication, mechanical, and electrical. All of those are 3 years. So how do we know, what do we have to do for visual, cleaning, lubrication, and mechanical?
So we need to go to chapter 13.
So we go to chapter 13. Panel boards and the switchboard. We're back to this chapter again, right?
Yeah.
So we were there before, and we went through the scope was fine. We went through that it doesn't address individual components, and then we were into frequency, and it says chapter 9 unless otherwise specified in this chapter, and there's nothing that specifies a difference from the table above. And then we get into, now the way this is laid out, they've got the visual inspection in 13.1, 13.3.1, because you have all of the periodic maintenance procedures. So you've got visual, cleaning, lubrication, mechanical, and then finally electrical. So for each of these items, which was in that table above, this will tell you what you need to do for the visual inspection and for the mechanical and cleaning and all that good stuff. So what do you think for physical? I mean, for visual? External, right? You got to look in the external condition of the enclosure. Yeah. Anything you can see. Labels.
Do you want to put that table up there?
Yeah, I can do that.
I think if you hit the little 3 dots, it expands it. So it might be a little easier. There you go.
So we got to inspect the external physical, inspect the anchorage. Anchorage. Is that like anchorage? You know, this is Multerkonkite. Verify the circuit.
No, I think we're talking about how it's connected to the physical ground or a building or those type of things. So
now test types. What's that?
So if you scroll down to the bottom, and it does talk about that, and it is explained in section 8.3. Again, a little bit of jumping around, but 1 is an online standard test. 1A is an online enhanced test. 2 is an offline standard test, and a 2A is an offline enhanced test. So where these categories came from, or the test types came from, is Nfpa 70B is to represent the minimum amount of maintenance that you can perform on a piece of equipment. And there might be inspections or tests or services that maybe you do because there's a problem, and you know that there's a problem. So you might do one of the enhanced tests to try to determine what the cause of that problem is. So those items were broken out from what I would call the mandatory tests. So your 1s and your 2s are your mandatory tests. Your 1As and 2As are your enhanced tests, which should be done, under certain conditions, or maybe even the application of the equipment might be a good idea to do a particular enhanced test based upon how that equipment is being used, or maybe even the criticality of the equipment. If this is critical to your process, go back to your enhanced damage. But again, it's not a mandatory one, but it might be something that you might choose to do because of your process. And maybe there's a financial or maybe something to the environment. Maybe if your water treatment plant fails, it might spill sewage into the Mississippi River. That would be a pretty significant problem, and the EPA might be crawling all over you. So there might be a reason to choose to do those.
So anytime you see a 2 that tells you you're going to have to establish an electrically safe work condition to be able to do that visual inspection.
Correct.
So that means if I'm looking at this table and I know I have to do this every 3 years, that means I have to establish an electrically safe work condition on this panel board to be able to do my visual inspections.
Yes.
Could you, I don't know if you've ever done this before, but did you ever see anybody break out the items to say, look, I'm going to do all of my I'm going to do a visual inspection. Say you do something every year, and you do what you do the voodoo that you can do, energized. That you don't have to put it into an electrically safe work condition. Nail those down, and then that could do you think it could reduce the time it takes to do maintenance when you do have to establish an electrically safe work condition? Do you ever see anybody break it out that way?
Yes, you do have customers who will do things, for example, the older protective relays used to have test switches, so you could disconnect them and test them while not taking the equipment out of service.
Okay.
So, you would take out A phase, test A phase, put it back, do the same thing with B phase. They were designed to be tested without and serviced without necessarily having to de-energize the circuit breaker that they were protecting. So,
right. So in this case here, I could do it, and I could do an external physical condition inspection. I can look at the anchoring and the grounding. I could also ensure maintenance devices and tools are available for equipment servicing. I don't know that should even be in the table for a panel board. I mean, we got to look at that.
Yeah.
And I can visually inspect environmental controls where provided. Any fans, heaters, thermostats. So I could go to my panel boards and do item 1 or anything that can be done energized and knock that off. And I could have that being done more frequently, right? Just as you're walking around the plant. I mean, you could tell each of your individuals that, I mean, if you had it on a phone and your personnel, as they walk through the facility, if they walked over to a panel board and they're looking at just the physical condition, they could open up the app, they could select the items for visual inspections and anything that they can do while it's energized and walk down through that list pretty doggone quick. Because I could imagine that if you're not removing covers and anything, you're just looking at the physical conditions. Visual inspections are probably very easy to do or some of these items are easy to do while it's energized.
Correct. And again, the de-energize things, your process is down.
Yep.
If it's a manufacturing facility, you're not manufacturing anything. So you want to minimize that time that you're not manufacturing. So doing as much of these type of items that you can do without having to take the outage, and as long as it can be done safely,
yep.
It's definitely a benefit to get it done. So
yeah, and in fact, this one here, the item number 3 on the list is verify circuit breakers, fuses, and overload elements are the right sizes and types and correspond to the drawings and power system studies. If I can get access in a panel board, I could open up the door and I could do most of that through the door just looking at my devices. Right? I mean, I could probably see everything I need to see from a visual inspection perspective.
Yeah, as long as, sometimes there's dead fronts and things that cover up labels, which is unfortunate.
Yeah.
But sometimes those dead fronts can be taken off safely. And if you're doing a thermographic scan, that's also a time to gather that data. So.
All right. So we've got to get moving. So cleaning and lubrication, those are pretty self-evident. Mechanical servicing, you got to look for your mechanical condition, ensure maintenance for the device. I see it says ensure maintenance devices and tools are available for equipment servicing. I don't even know why we put that in the table. That should be like something up above that just says if you're going to work on it, make sure you have your tools.
It should be part of the EMP, yeah.
Yeah. Inspect anchorage and grounding, even the mechanical. Verify filters are clean and in place. So some of these devices, some of this is going to be done. Pretty much everything in the mechanical is offline. So you're not going to do any mechanical servicing while it's energized. And then what's the other one? So the other one is electrical. So this is let me just try to expand this one. These are your electrical tests. You're going to check for the hardware connections, measure insulation resistance. How do we do that?
So now we go back to chapter 7, and we have fundamental tests.
Chapter 7. So I gotta go back to chapter 7, which is called fundamental tests. Is that the insulation resistance quality?
It will give you different types of tests that you might need for insulation resistance quality. Correct. That's the name of the test. So,
all right, and that's 7.3. So all of those are under. Well, 7.2 is your bolted bus connections, conductor terminations, and conductor connectors. And you can do infrared thermography, you can do thermal sensors, contact resistance tests, torque verification. And then in 7.2.2, newly installed threaded hardware value torques. And then 7.3 is your insulation resistance quality. So what were we looking at again in that one? In chapter 13. That was electrical. What was the measure insulation resistance of control wiring and of the main bus? Insulation resistance of the main bus. So yeah, so that would be, so 7 will tell you how to do that and the tests you need to perform. And this is a 480 volt panel board, 1200 amps. Okay, then what? Okay, so you have to do all of those electrical tests, perform the operation, test the control power transformers if there are any in there, all that good stuff. Isn't that the overcurrent device you're testing though? No, not necessarily. When you say insulation resistance, none of this is on the breakers that are inside or fusible switches.
No, that's number 4 where it says test protected devices and systems. So that's where you would, now you have to jump to chapter 15 and go through that list.
Okay, so if you have a circuit breaker, so take the 1200 amp main molded case circuit breaker with electronic chip unit.
Correct.
What would we do?
So we go through there. We have the same type of thing. We have our visual inspections that we do. Cleaning, and you will notice on molded case, those are sealed, so they're not meant to be taken apart. So that's mostly cleaning the exterior of the frame. Lubrication, again, molded case circuit breaker, it says NA on that because, again, that breaker is not meant to be taken apart. It's a sealed item, factory sealed with a factory seal on the side of it.
Right.
If you were to remove or open the breaker, you would void the listing of the breaker.
Ah, that's right. Yeah, you can't take it apart. So if it's okay, so yeah, molded case. That's why the power circuit breakers and the insulated case circuit breakers, I can do a little bit more on it. Even though an insulated case circuit breaker is still a molded case circuit breaker, I can do a little bit more. I can break it down a little bit further than I can a standard molded case.
Yeah, because it has the stored energy.
Yes.
So it's a little bit more maintainable than a molded case is.
Yeah. And then this is the lubrication. I'm not going to lubricate a molded case circuit breaker at all.
Correct.
So insulated or low voltage power breakers, yes, there's some lubrication I can do, but not on a molded case. That makes sense.
And then the electrical test is probably something that we should discuss on this.
Okay.
So for example, here we have molded case circuit breakers, 250 amps and less.
Yep. Oh, that's
and
right.
Then we have 250 amps and greater. And again, taking a really sharp look at the 2s and 2As, we'll notice that so verifying calibration of all the trip means a number 5 by the manufacturer's test set is a 2, and then inverse time trip tests at 300% of rated continuous of electronic trip circuit breakers is a 2A. So that's an enhanced test for an electronic circuit breaker, but it's a mandatory test for a thermal magnetic breaker.
But when it's a large 250 amp or greater breaker, over 250
Right.
amps. I see. So for the larger breakers, they want you to run that 300% of rated. For the smaller breakers, it's optional. Not optional. I can't say optional. It's enhanced.
It's an enhanced test.
Yes.
So it's not a mandatory test, I guess is the best way to say it. And then it also gives you, because again, we're talking about the minimum amount of maintenance. So for electronic trip units, which have those, which allow you to test the breaker using a manufacturer's test set, or some of the newer breakers even let you do it with just a USB connection to a computer.
Right.
You can use that to test the breaker as opposed to having to use the big high current test set.
Okay, so for the 225 amp breakers, I have to do thermography annually. I have to operate the circuit breaker auxiliary and control devices, such as local and remote control switches. This is the electrical tests. Coils, and I mean, I don't know that there'll be any auxiliary control devices that are on there, but if there are, I've got to do that. And then I have to do a test current limiter resistance, if there's a current limiter in there, which some of the multi-case may have it, but I doubt these small multi-case are going to have a current limiter.
Yeah, not unless you're like in New York City or someplace with super high fault current will you see current limiting breakers in switchboards and panel boards. So
yeah, then you have to check the status of the rating plug battery. And if you have a standard thermal mag breaker, you don't have a rating plug battery in it. Small one, right? Especially we're at a 225. And then you have to test the arc reduction technologies. And if it's a standard thermal mag breaker, there's no electronic trip unit. You're not going to have an arc reduction technology on it.
correct.
So the electrical tests for a 225 amp breaker are pretty minimal.
Yes, they are. I see we have another question here about you need to
Exercise.
I think that's exercise the breaker, that lubrication trip mechanism. That is correct. So exercising the breaker is necessary even on multi-case circuit breakers to keep that lubrication nice and freed up.
And that's that would be a mechanical test, right?
Yeah, that's under mechanical servicing.
And what it says is operate the circuit breaker 3 times. Now, it has it as an offline standard test. You probably would not want to operate the circuit breaker 3 times while it's pulling load, right?
Yeah, definitely not.
Yeah. So, and because I mean, that's just something you would want to do in an electrically safe work condition. That'll cycle that handle, turn that thing on and off. And I'll tell you what, we say turn that thing on and off. I go like this, but some of those breakers, it's more like a.
It is.
Yep. Check all accessible electrical hardware connections for correct torque. And how do we check torque? What chapter do we go to?
That connections, the
Torque.
fundamental test, chapter 7.
Very good. Chapter 7. So, and what I think that tells you is 90%. You torque it at 90% of its torque values, and if the bolt or the screw, whatever, doesn't move, then you verified torque. And if you have to you can't retorque it. If you have a problem with torque, then what you have to do is unscrew that, take the wire out, cut it, clean it, put another piece in. So you've got to do a fresh termination. You have to verify correct operation of shutter assemblies and draw-out breakers. And we left it in multi-case circuit breakers because there are draw-out multi-case circuit breakers, aren't there?
Absolutely.
Yep. Verify operation and alignment of mechanical safety interlocks. And Robert says that he's had them not turn off, even though it was in the off position, meaning the contacts welded. Wow. That's a tough one. And for a multi-case circuit breaker, you don't have to measure and record a trip bar force. because there's no trip bar, right?
Correct.
And for insulated case and low voltage power breakers, those are enhanced tests anyway. I like it. So those are the mechanical tests. So you have to do that. You have to look at, so we looked at chapter 17. We looked at chapter 13 for panel boards, and you have to do all of those tests. We established, so the first thing was, we said what is the equipment that we have. We have to figure out where it's at, figure out the condition, 1, 2, or 3, right? You establish the condition based on chapter 9. That establishes the frequency. Then you go to chapter 13 for panel boards, and you follow all of those requirements from a frequency of maintenance and any periodic maintenance procedures, and refer back to chapter 7 and chapter 8 as appropriate if you're doing torque or any of those measurements. And, here's a good question. His question is, do you see this one?
Yes.
If for torque, is there a different way from stranded? I'll tell you what chapter 7 says for torque. Torque verification. When using a calibrated torque wrench to confirm the torque of previously installed threaded hardware, the retightening value shall not exceed 90% of the manufacturer's specified initial torque value. It says where initial threaded hardware torque value data is not available, torque value shall be in accordance with table 7214A, etc. Let's see if there's anything in there. It just says bolt torque values for electrical connections, and it has the bolt diameter and the torque. It doesn't say anything about stranded or solid conductors there either. And then in table 72142, let's look at this one. It has the bolted diameter, whether it's a non-lubricated thread or a lubricated thread. There's nothing in there for stranded versus solid. Let's look at table 72142C. Torque pound-feet lubricated and the bolt. And this is for aluminum. Nothing in there about stranded. So no, Thomas, I would say there's nothing in 70B, and I don't believe there's anything in the product standards that speak to whether or not it's stranded or solid. I believe the manufacturer will address that in their labeling. If there's anything specific for torque that the manufacturer would call out as part of the listing. Let's think about that. I was trained to shake around stranded wire while tightening. When you say shake, do you mean tremble? You know what I can do? What if we looked at the standard for, would we look at panel boards, you think? UL 67? Yeah. So I'm going to go to UL, and I'm going to go to 67 panel boards. And I just downloaded the latest edition for UL 67, and we're going to do Control F, torque. Tightening torque is on page 109. And what it says in tightening torque, it says 109, 6, 7, 8, 9. All right, here's what it says, Thomas. A panel board shall be marked to indicate for each wire connector in the panel board that is intended for field wiring. If different connectors are used for line load neutral, shall be clearly marked. The torque may, okay, so there's nothing there about the type of wire yet, stranded or solid. Shall be marked maximum torque applied. I don't see anything in here they talk about the conductor sizes and the size and the material. That makes a difference.
I think someone has given us a clue in the chat, UL 486.
That's for wiring devices. Robert from Omaha. I'm like, oh, here we go. Look at this. Here we go. Example of tightening torque marking. So this would be the marking on a panel board. It says equipment ground terminals, large hole for 310 American wire gauge solid copper conductors, torque screw to 45 pound-inches. For all other wire combinations, torque screw to values shown in column B of the table for the conductor size installed. So it does call out for solid conductors. Now, it doesn't specifically say stranded. You know what I'm going to do is I'm going to search for stranded.
It says all other. Yeah.
Yeah. Small hole, a connector with a slotted number 10 screw, a slot width of 0.047 inches, and a solid and a slot length of blah. For single conductors, the wire range for this hole is 6 to 14 aught. Multiple conductor combinations with a stranded configuration are as follows, and it just deals with the number of conductors that you can put in those terminations. And then it gets into the actual torque value. So to answer Thomas's question, I think, Scott, the product will have the label, and if the product has determined that you would probably use stranded conductors, because there's probably some conductors that just aren't going to be stranded. They're going to be solid, depending upon what the equipment is. But if there is a difference between stranded and solid, I would look to the product for the guidance on torque. If it just says this is what you torque it to, and then it doesn't matter if it's stranded or solid. But if it says, for like that said, for solid, this is what you do, or anything other than solid, then this is how you deal. Then you have to do something different. Good question. And Thomas, I would not. I don't know about shake around stranded wire while tightening. I don't know if that means I'm shaking. Oh man. Tate recommended tools for material type of electrical equipment maintenance. Cleaning, lubrication, if manufacturer instructions aren't available. Well, so cleaning. So let's look at that real quick. We were in panel boards, right? Remember,
Yeah, I do think we always reference the manufacturer because most manufacturers' equipment manuals do specify, especially lubrication, if it's required, the exact product that needs to be used. I'm not sure that I can recall a specific product that does not specify its lubrication.
right. And so I'm looking at panel boards right now. The cleaning just says keep it clean and contaminant free state. Bus insulation, cable insulation, all the terminations. There's no tools or anything that are specified. Lubrication, it says terminating devices, mechanical parts and operating parts that exist to open, close, insert, and trip a circuit breaker, switch, or protect device shall be lubricated as required in accordance with manufacturer's instructions. It doesn't give you any other guidance. Now let's go to circuit breakers, because I believe in circuit breakers. I'm not gonna break out in song. So electrical equipment surfaces, enclosures, and insulating material shall be kept in a clean and contaminant-free state. It says if contamination such as dust, dirt, soot, grease, or moisture is found, cleaning shall be performed in accordance with table 15.322. And it says in 15.322, it says clean insulating surfaces of the circuit breaker using a lint-free dry cloth, brush, or vacuum cleaner, and avoid blowing materials into the circuit breaker or the surrounding equipment. So there are tools listed for cleaning for circuit breakers. And in my opinion, Scott, that should be also in panel boards, because you could have panel boards like where you have the trough, like down in the bottom of the trough, and you had a picture in our last presentation. There was a lot of dirt and debris down in the bottom of the panel board.
Absolutely.
And you can vacuum that out, but you just don't want to blow air back into the panel board. You got to be careful of that. And then on lubrication for breakers, I know we had an extensive discussion about this. You're not going to lubricate a multi-K circuit breaker. And I think to Robert from Omaha's point, you're going to cycle it, right? You're just going to turn it 3 times in non-energized state. Now, it says apply a thin coating. This is for insulated case and low voltage power breakers. Apply a thin coating of conductive lubricant to exposed contacts as specified by the manufacturer. And then a non-conductive lubricant as needed to mechanism parts as specified by the manufacturer. And then there's moving and sliding parts. Everything says as specified by the manufacturer. And there's no annex material for this. So Thomas's question, I like that name, by the way, or Tate's question was, if the manufacturer's instructions are not available, what are the tools or material type for electrical equipment maintenance, cleaning and lubrication? We sort of got cleaning covered, but lubrication, you got to be very careful, to your point about applying lubrication that the manufacturer doesn't tell you to apply. What could result, Scott?
For example, I do have a picture in the presentation that we gave of the improper lubrication being used on the contacts of a medium voltage circuit breaker. And so because it was not the correct one, it caused an overheating condition on the stabs where the circuit breaker wraps into the stabs in the back of the cell. And that overheated and resulted in a complete failure of that particular circuit breaker. Basically melted it.
Was it in our presentation that we gave?
I believe it was. It was.
I don't see it. You know what? I may not have the latest.
Yeah, that might have been an update. So
yeah, that's what I think it was. All right, so you could have a malfunction of the equipment, and that could lead to an unintended rapid disassembly in the field. So Tate says manufacturer may not exist anymore, and original documents may not be available. You know what would be good, Scott, is possibly some annex material to address exactly what he's talking about, or she's talking about today. That might be a good idea. But very good point. And then Robert says, what about dust and contaminated effects accumulating inside the switchgear? Oh, dust. So one of the things I learned, and I think you taught me this, dust at medium voltage is not good. Right?
No, it's not.
So a little bit of dust can go a long way to achieving an unintended rapid disassembly in the field. So dust inside of especially medium voltage equipment can definitely be very detrimental to the longevity of the equipment and safety of personnel. Very good question. Robert says incorrect lubrication or method of applying could affect insulation on conductors or other components. So that's true too. That's true too. Depends upon where you're putting that lubrication, all that good stuff. And it could accumulate dust if you put it in the wrong locations. So if you don't know where to put it, you could attract dust or other maybe metallic components, right? And I think I remember seeing a picture. Where was it? I know where it was. It was at the electrical safety workshop. There was a gentleman from a very large organization that we're probably leveraging their platform today, maybe to some extent. and he was showing me a picture of a piece of equipment where there were like metal. It was like metal. It was like very fine metal that was on a device, and it was in a magnetic, almost. It was like in a circle, like it almost like made like a little bit of a heart, and you could tell that with the magnetic fields, you can see exactly where the magnetic fields were because it separated all of that into little lines, and that implied that those shavings were metallic in nature, and that's ungood. So Robert says 421 microns will hang in air in explosive quantities. I met a micron once. Party animals, I'm telling you, those microns. And when they all get together, oh my gosh, that whole family, the micron family, unbelievable. I love it, Robert. Cool beans. Anything else, Scott? I just called you Robert.
No, I think that's it. We're a little bit over, so
yeah, and
maybe we'll have to come back and do another one.
We hit over 100 comments, so thank you, everybody. We had over 100 messages on this stream, so that means we had a very engaging audience. I really appreciate the questions and the dialogue. Thank you, Robert and Thomas and Tate. Hopefully, I'm getting that right. Thomas Plunkett. Coming in on LinkedIn. Don't forget to get over to YouTube and subscribe. Hit the thumbs up. And if you have to hit the thumbs down, hit it twice. So, all right. Well, Scott, I think it was a good session. I learned something.
Real good.
I appreciate your time, sir. Any parting thoughts on maintenance?
It's important, folks. And it's connected to safety. I think that's the whole purpose of changing this from a recommended practice to a standard, is to give some guidance to everyone out there on some of these items, especially frequency, which, we had a lot of public inputs on 70B around frequency. So I think that was a definite point of why we addressed that specifically in NFPA 70B.
Excellent. And it looks like Tate is Alex's father in the Philippines. So Alex, thank you. Now we know who you are. I know it's a he. I wasn't sure with Tate, so hopefully you forgive me for that. So Alex, thank you for all your questions, and hopefully we answered all your questions. So. And Robert and David Engelhart was on there too. So yes, I agree with you, Scott. It is all about electrical safety. And I always tell people, if you're following this and you're not doing maintenance, you're not following this.
Yeah.
Right. So 70E is critical to, and 70B, it's the trilogy. Install it correctly, maintain it correctly, and work safely. So.
Yep.
All right. Thank you, Scott. I appreciate your time. And thanks everybody out there. Alex, thanks for tuning in. David Engelhart, Robert from Omaha, Thomas Plunkett, thank you for joining in as well on LinkedIn. So, all right, we're going to sign off. Everybody out there, thanks for all you do for the electrical industry. Thanks for what you do for electrical safety. And remember to stay safe, and please stay healthy. So I'm looking for my ending. I gotta hit a button, and I believe it is, there's me, there's the chat, there's the monitor, guest, tools. There it is. Eaton ending. All right, there we go. Thanks, Scott.
Everyone.
Thanks, everybody.
Thanks, Thomas.
Take care, and we'll see you next time. And maybe I'll lasso Scott in doing another program.
Sounds good.
Take care.
Bye.
And let me mute.